I'm going to talk to you today about the audio subsystem that we announced and just released last month, actually, in May, so it is June now. So I'll give you an overview of the audio market, then we'll talk a little about the hardware and the software, and then the prototyping environment that's available around it. So it's no secret that more and more IP is being used in SoCs, and there's a lot of reasons for that. But as the IP usage increases, of course, you end up with potentially hundreds of IP blocks on an SoC, and there's not enough time to integrate all of that. And so customers have been asking us for years, and we've been talking to customers for years about putting together subsystems. They're complete solutions, so sort of a one-stop shop, if you will, for a corner of the SoC. And that's what we have. There's a number of reasons why people are looking for subsystems. Certainly convergence is bringing a great deal more complexity onto SoCs. You just look at the application processor, the application environment. Inside of a cell phone today, it's very complex. I was looking at, we market sensors at the other end of the spectrum here, and or processors for sensors. Right now there's 14 sensors in a smartphone, and the number's increasing. It's a very sophisticated environment. There's not nearly enough time to develop this. The integration complexity, the manufacturing complexity is lengthening design times around SoCs. And at the same time, the market's demanding shorter market cycles, shorter development time to meet those cycles, and the cost to develop a chip is increasing. So as a result, companies that develop SoCs are looking for ways to lower their cost. And they're making that decision more and more between developing and buying or licensing IP and subsystems. Another challenge, sorry, I forgot this slide builds, is verification, which is a huge deal in an SoC today. We spent about 200,000 hours verifying just the audio subsystem. So 200,000 hours of server time verifying the subsystem. Now, we have a lot of configurability in there and things that we had to look at, which you probably wouldn't implement in your own solution, but it does make it much more reusable. It spreads it across a lot bigger application domain, so it's easier for you to use. Even so, the verification effort inside of SoCs today is becoming enormous. It's a huge cost. We hear customers telling us it takes longer to verify the chips than to develop them. And obviously it's another cost that needs to be controlled. With a complete subsystem, that block is already verified. You can drop it in and you can be comfortable that it will work in the environment. So and another issue around audio is typically not a center of competence for most of our customers. They don't have a lot of audio expertise inside. There's a huge range of audio formats because a lot of things are now connected to the internet, so you don't really know necessarily what format the chip you're developing is going to be running, so you have to support them all. There's also the expansion from stereo to 5-in-1, 7-in-1. We have customers talking about 9-in-1 surround now, or putting out stereo and wanting to create the surround environment just from 2 speakers. It's very common also. Higher levels of sampling, precision that's required just so the audio sounds better. And then again, the whole sound processing that's going on where you're taking potentially highly compressed audio, bringing it back, making it sound good, playing it out of a nice environment like this. It's my cell phone. You can imagine the monster speakers in this, right? The 6-pound magnets on those subwoofers, no, not at all. I mean, these are like paper thin, really tiny, and actually it sounds pretty good when you play music out of it. Your phone's probably the same way. That's a result of post-processing. They actually take and can tune the environment to the audio you're playing. Now, all of that is very complex. There's a lot of effort to put it together. And again, it's not an area where most of our customers feels it differentiates them or they have a lot of confidence. And yet, great audio makes great products. They did a study where they took 2 identical TVs and they put really good audio on one and just average audio on the other. people consistently rated the picture quality of the TV on the one with good audio better. Same TV. Good audio makes great products. And so we put together this subsystem. Now, I've been in this industry for a long time. I've been involved in microprocessors for 25 years or so. We always talked about subsystems, but until we got into the meat of it, it wasn't really clear what we were in for. Now, we put together the hardware. The hardware is actually kind of easy. The software is the piece that's extremely complicated, because the software has to not only play with the processor that's in the application, the audio processor, it also has to play with the host side of the application. This is a very complete solution where it can be dropped into an application. We even have a plug-in for the host if you're running GStreamer. So you don't even have to do that. It makes the system look essentially to the software guy that's programming on the host. It looks to him like a series of function calls, which is ideal. He doesn't have to worry about the hardware. He doesn't have to worry about the underlying software. He just implements the system, the subsystem, from a host perspective. So it's very easy to do. And then we have a complete development environment. In fact, we're over in our booth, they're demoing today the transactors, which work between the virtual environment that we offer with the HAPS FPGA environment. So it allows you to cross that boundary very easily. So you can run, in this case, you could run, say, the audio subsystem on the HAPS board. So you could run it at good speed and run a lot of the codecs. And then you could run the host environment virtually. And you can plug them together and they wouldn't know the difference. It worked quite well. Now, we did fully integrate this, but we also made it configurable. The system can be used across a very broad range of audio applications. That was obviously intentional. We play in a broad range of the audio market, but it is fully integrated, fully configurable, and yet it's fully verified as well. And then it works obviously with the virtual environment that I was talking about, both software and FPGA. And it's actually very easy to configure, even though there is a lot of configurability in there. We have tools you can use. You can configure the subsystem literally in about an hour for your application. That's very specific. That's hardware and software configured specifically for your application. So this is the hardware portion of the audio subsystem. What's in light blue is the subsystem itself. Includes a processor, some buffering, memory, a number of interfaces. On the bottom, I2S and SPDIF are obviously digital interfaces. What's in orange there is the analog interface. We actually partition the analog codecs themselves off chip or outside of the subsystem because we don't know what process you're going to run those on, you know, whether it's 65 or 40 or 28 or an older process for that matter. But I'll show you a slide in a minute. We verified all the way to the interface so you can easily attach any analog D to A or A to D that you want to. In terms of configurability, there's a number of different processors you can use here, a couple different selections you have. The interface as well as the digital interfaces are all configurable. You can have, you know, one I2S interface or 100. It's up to you, whatever your system needs. Now, really, the hardware is the easy side of the problem here. We do have two ARC audio processors available. One's a single core, the AS211 is a single core processor. The AS221 is a dual core processor that we developed so that you can support either a large number of codecs or very sophisticated high definition audio solution easily while managing your power consumption. We also have customers that license the AS211 because they want to run the codecs on one core and they either give their customer access to the other core or they do the post-processing on the other core. So it gives you a nice way to partition as well. But you can use either of those. They're both there. They're both very tolerant to system latency, which can be important, especially in systems that implement audio and video, because video is going to dominate or is going to have priority over the audio. We've seen systems with as much as 500 cycles of latency. This is very tolerant. You see very little performance degradation, where with some of the other solutions on the market like Hi-Fi or Civatique Lite, you see substantial performance degradation as the latency increases in the system. So I was talking about the analog interface. So you can interface to anything analog that you want, whether it's a microphone input, headphone output, speaker output. But we verify up to the interface there where the analog components plug in, and you can plug those in very seamlessly. Again, we don't know which analog components you're going to use because, again, we don't know which process you're going to run in, and this is designed to be used across all process capabilities. On the other side, we have that's an AHB or AXI bus. Where you can plug in the host processor, and that host processor, we're host agnostic here. We don't really care what host you use. Now, we'd prefer you use an ARC core host, but if you want to use ARM or MIPS or Intel x86, that's fine too. We interface quite well to all of them. And then also that AMBA bus gives you access to all the interface IP, HDMI, MIPI, whatever else you're running in your system. One of the things we did do is, of course, Synopsys offers an HDMI interface as part of our interface IP. And we have access, obviously, to the inner workings of HDMI as well as the inner workings of the audio subsystem. So we actually created a back channel, and that's what's on top there, where you can directly output from the subsystem into the HDMI interface and literally bypass the bus. So the bottom is what you would normally do, and there'd be some kind of buffer there to manage it. But you can bypass that, connect directly into the HDMI interface. And that's some of the advantages we have, obviously having control of the audio subsystem, but also the interface IP, whether it's HDMI, MIPI, or something else. And again, it seamlessly plugs together. You don't have to spend a lot of time thinking about it. I just put this slide in to let you know that we've also have full support for clock management, power control. There's a number of different clocking modes that are listed there. But the system is complete. It's not just high level, here's a processor core and here's some memory. It's the whole thing in terms of hardware. It's the whole thing in terms of software. This is a diagram of the software. What's in blue on the bottom is the hardware itself with the audio processor on the or audio subsystem on the left, and then a host environment on the right. Again, we're host agnostic, whether that's ARM or MIPS or ARC or x86. We really don't care. Now, what we do is we obviously stack the software on top of that, and that's the operating system, the drivers. We have about 90 codecs available that run on the platform. We license those, again, individually because we don't know. Every customer wants a different set of codecs. We support them all, so you don't have to. We actually take them and optimize them so they run in minimum bandwidth with minimum memory requirements on the processors. And then we have a complete framework the codecs plug seamlessly into to make it very easily to use the codecs with the subsystem environment. Now, over on the right there, you'll see the audio plug-in. So we deliver an audio plug-in for GStreamer that plugs straight into the host application. The interface between that plug-in and the subsystem is complete. You don't have to develop anything else. And so, again, for the software guy that's writing the program for the host, the subsystem just looks like a series of function calls. And for those guys, that's wonderful because they don't want to spend time trying to figure out the register set or how that works or anything else. It's just play, do whatever they need to do, and it does it. Oh, there's something else I was going to say, and I forgot what it was. So, again, the plug-in is seamless, it's easy, it's complete. And the idea was that, as you can see, the subsystem block is self-contained. Now, we deliver this, the IP is delivered as RTL. The software is delivered as source code. We don't hide it or obfuscate it or anything like that. If you want to mess with it, there's enough rope there you can hang yourself, and we're happy to let you do it. You don't need to, though. You can use it as it is. Now, we recognize around the edges people like to be able to mess with things, so that's fine. And that's why we deliver it as source and RTL. But again, it's a complete solution that you can implement literally today in your design. This is just a list of a very partial list of some of the codecs that we offer. Again, the full range of HD audio codecs from Dolby, DTS, SRS, Microsoft, and others. And these are all, by the way, we actually go to the manufacturer. So if it's Dolby, we take our codec back to Dolby and we have them certify it. After we've optimized it for the platform, we have them certify it. We're the only ones that do that. And what that does is it makes it much easier for you when you use that codec in your system, because you're going to have to go to them and get your system certified too. But if you tell them, oh, we're using one of Synopsys codecs, they know they already certified it, so it'll be much easier for you. Again, the system's fully configurable. Whether it's in terms of the processor core, you can implement it, just a huge range of configurable selections or options on the cores themselves, so you can tailor it very specifically into your application, as well as the bus interface, the number of digital I/O. You can actually configure the analog interface to some degree, and then of course the software itself. So as I mentioned, we have full support. I didn't bring the demo here today. I'll have it here tomorrow and Wednesday. But we have full support for virtual implementation. The demo we have of the audio subsystem right now is implemented actually it's implemented in FPGAs, not in the virtual environment. We do have the virtual capability that we just brought up as well. So you could potentially implement your whole system in a virtual environment here if you wanted. The host, the audio subsystem, and everything. You could split them across to implement the audio subsystem in FPGA, the host environment virtually. It's up to you. It's a very complete environment. Makes it very easy to develop the host application using the subsystem. As I mentioned, the demo itself we have, and that is actually the demo, built up on a HAPS environment where we implement an ARC host environment supporting the audio subsystem. And I'll have that up here tomorrow. So this is actually a layout of the subsystem. This was done with a 211. I put some sizes over there on the side. In the 40 nanometer process, this will run just shy of 800 megahertz, 794 megahertz. So it's certainly very capable. In that regard, that's a lot more performance than you're going to need in most audio applications. Typically, we see our customers running 300-400 megahertz typically in the audio environment, and that's if they're doing pretty high-end audio. So again, you see a very small size. This was done in a 40 nanometer LP process. So the SoundWave Audio Subsystem it's a complete subsystem, hardware, software, the complete prototyping environment. It's fully verified. It literally reduces years of development work. We spent 10 man-years developing this subsystem, and you can implement it in about an hour for your SoC. So quite a savings. And by the way, that's when I say implement, again, hardware and software, done. You can implement it with a single or a dual core, so you have a great deal of scalability depending on what your application is. So you control performance, power consumption. It is fully supportive of stereo, of course, but also 5-in-1, 7-in-1. Other formats as they come out will be fully supported. We have a complete range of post-processing software available for it. We actually deliver with the subsystem basic post-processing software. It allows you to do what I would consider kind of a minimum post-processing for most applications. Obviously, if you need something more specific, we have codecs from Dolby and DTS, SRS that support much more capable post-processing. Again, it's an integrated environment. It's configurable. It's fully supported in a virtual environment, so you can develop your software and can be implemented in about an hour.